Here we are on 2016 Volkswagen GTI. We have pulled the spark plugs out all and I'm going to be inspecting them. As you can see, this is cylinder 1. It is pretty oil fouled there towards the top of the plug. His 1 and 4 cylinder are seeping oil into the plugs and fouling them, but the tops, the electrodes here look really good. Here is cylinder 2. As you can see, a lot less oil than cylinder 1, and the electrode also looks very well. Here is our wiring diagram. We have our power, our ground, our reference, and we were going to do an ohm test, but it is not able to do because of a chip inside here that basically doesn't allow us to get in good reading, and it just showed 1.1 mega ohms. And then over here you have this feedback wire.
So we're back probed into the signal wire on this ignition coil for the Chevy Malibu now. The way this system works is the PCM gives the ignition coil a signal or a command to fire. The chip inside of the ignition coil then takes that command and fires the coil itself. So as you can see here, we got the pico readings up. You can see most of the time on the signal we have a 0 volt reading, but when the ignition coil fires, it spikes up to about 5 volts, and that's the PCM giving that coil the command to fire.
So here we are tapped in the pico on the voltage supply power circuit, same as before, how they're all connected on that same wire and dropping the voltage, spiking down there. And we're going to be unplugging one of the coils to create a misfire and seeing what's happening. And as you can see, the graph starts to wave much more unpredictability, much bigger spikes because of that misfire.
So we're on the Corolla. We have our digital multimeter hooked up to the ignition timing wire coming from the PCM, giving that timing signal to the ignition coil. We have our multimeter on hertz. As you can see at idle, we're getting about 400 hertz at idle, fluctuating between 350, 400. So that means the PCM is commanding the ignition coil to fire about 300 to 400 times a second at idle. If we rev it up a little bit, you can see it go up into the kilo ohms because a higher RPM means the ignition coil has to fire more often. So it spiked up to about 1.5 kilohertz there, as you can see.
Here we got the pico hooked up on the Corolla with the ignition timing wire, blue clamp, and the ground with our amp clamp. Looking at our pico graph, you can see the 4 volt square wave created off that ignition timing wire where it spikes here for that cylinder 4, telling it to fire, and you can see the feedback from the other cylinders as it's idling here. And then the red spike is the amperage getting up to almost 12 amps. I think it's around about 10, and you can see that of the magnetic field going up and crashing as the cylinder fires.
Okay, so we switched over to the 2007 Buick Lucerne to get some easy secondary voltage at these plug wires. I went ahead, took the paddle thing and put it on the plug wire to get our secondary voltage waveform. As you can see, here's the dwell time where the ignition coil is building its magnet, and then finally when it takes away its ground, releases the magnet, collapses, get a voltage spike, as well as a little burn line here where the spark plug is actually firing, crossing that gap, and then a little oscillation as we go back down towards ground.
So here we are going to be doing a power balance test, and as you can see, the car is warmed up and is sitting around 750, 730-ish RPM. Now we're going to unplug the coil. After unplugging cylinder 1, the RPM has increased to about 900, 950, kind of bouncing around there. If you want to unplug another one. about 800, 850-ish, a little bit lower, but around the same. About 800, 850, bounce around there. Same as cylinder 2. And about 800s, saw a little bit of the 700, a little bit lower, but all around in the same RPM range.